Okay, hello everyone. Thank you for joining today's Mobex webinar. My name is Freddie Holmes. I'm part of the editorial team here at Automotive World, and I'll be your host for today's session. Today's presentation is brought to you with our knowledge partner AVL, and will investigate the link between supply chain challenges and cybersecurity. Leading us through today's topic will be Harald Petschnik, Business Innovation Manager for Vehicle Software and Cybersecurity at AVL, as well as Guy Gilam, who is Head of Product Marketing at Cybersecurity Technologies. We'll follow up the session with some audience Q&A, so do send in your questions and we will get to those at the end of the session. You can ask a question at any time by typing it into the Q&A box on your screen. It's just at the top in the center there. After the webinar, we will also send you the presentation slides and a video recording of the event. With housekeeping out of the way, I will hand over to today's expert speakers who will get us started. Harald and Guy, over to you.
Thank you very much, Freddie, for the kind introduction. And I'm happy, together with Guy, my colleague from Cybersecurity, to present you together our interesting topic, a lifecycle approach to vehicle cybersecurity in case of supply chain shortages. Already Freddie did the introduction. Maybe it's then also worth to introduce a little bit the companies we are working for. So AVL is the world's largest and independent company for automotive engineering, testing, and advanced simulation. We have around about 11,000 employees all over the world. And we have own security engineering teams working on automotive cybersecurity, but we are also providing tools for more efficiency during the cybersecurity process. Guy, to you, please.
Thanks, Harold. Hi, everyone. I'm Guy from Cybersecurity. I head product marketing. Cybersecurity is a market leader in product security. We enable automotive OEMs and their supply chain to keep the products they build secure and compliant from the design to post-production.
So we will go into the content now, to the presentation. So before we speak about the topic of cybersecurity, I think it's really worth to take 1 minute, look a little bit back into automotive history and the aspect of software within the vehicles. We have seen over the past that within the traditional ICE-powered cars, software has taken over the role to control different components within the powertrain. Think about the automated transmission or the electrical control unit that are optimizing the emission and the drivability. And now with electrification, more and more software was added to the powertrain and to the vehicle. For example, to manage these integrated elements, integrated components, the electrified with partially the combustion-powered components in an efficient way, with the target, of course, to optimize driving range, emission partially, and drivability. And with automated driving now, software complexity really rapidly increased. The eyes, the brain, the legs, all the driver at the end is replaced by the vehicle. And this needs, of course, high-tech sensing, needs sophisticated software algorithm, and demands at the end connectivity to the vehicle and his infrastructure. And when we think about a software-defined vehicle, our future approach of driving cars so that all the function is software defined. We even put the vehicle 24 hours into the internet, so it's permanently connected to the outside, to the infrastructure. And all that software and connectivity, this brings, of course, also vulnerability. And a vulnerability is simply spoken a hole in the software or in the hardware where cyber attacks can happen. And attackers, they're trying by nature to misuse the system in order to find ways to enter to the car. And with every sensor embedded software element, the attack surface of the car gets larger and larger. And vehicle, they're becoming a lot of interfaces, such as Wi-Fi, Bluetooth, GPS, physical interfaces as well we have on board, of course, like the OPD and the USB. And with ECUs round about plus 80 in the vehicle, in total, it's really a huge attack surface that could be exploited by the hackers. And there was a statement from Forbes a few months ago that most probably every automotive manufacturer has been hacked up to date. And this statement is also difficult to support through facts. But what we can really see in the databases is if we have a look into our common vulnerability database, that it really pushes the number of known vulnerabilities really increased a lot in 2021. And in this year, this trend is likely to be continued. If we think about managing then these vulnerabilities, this is a never-ending process, and it's manually really not easy to handle because the whole vehicle life cycle has to be considered. And within the design phase, we might identify risks. We have to take known vulnerabilities into consideration, but also we have to look about potential 0 days. And in the development phase, then we are adding also real components to the car. And sometimes it's really difficult to trace the supplier of these components. And with these components, they also bring vulnerability on board that needs to be considered. And the OEM, the tiers, they have to react on that. And in the post-production phase, it's the most dynamic situation. It's a constant battle between the attackers and the defenders. So vulnerabilities, they're getting unveiled, they're getting known, they were documented in the databases, and 0 days suddenly appear. And both sort of vulnerabilities have to be detected. They have to be assessed based on the risk, so the impact and the likelihood. And also the OEM has to ensure that those vulnerabilities are rapidly fixed with software updates over the air, but also in workshops. So you can see managing vulnerabilities on a single vehicle, that is an effort. And this effort even scales up with the variety of models and variants and derivatives. So we have a huge complexity as well in the portfolio of the OEMs. And all these different vehicle variants have to be monitored on vulnerabilities. And in times of chip shortages and a complex supply chain of an OEM, the situation is getting more and more tougher. So please, Guy, give us some insights on this topic.
Thank you, Harald. So supply chain is definitely another area that is impacting cybersecurity. Now, everyone on this webinar is aware of the extremely complex automotive supply chain, and unfortunately, things are getting easier. From chip shortages, a global pandemic, regional conflicts, and even cyber attacks on manufacturing lines that cripple production, as was recently the case for a Japanese manufacturer, we are at times with great, or rather greater, uncertainty. As one expert I recently read about wrote, it's not a single black swan event. We have an entire flow coming at us. And I think it really represents well the situation that we are now in the past couple of years. And manufacturers are reacting to this situation. They are looking for more agility in their procurement and in their manufacturing efforts, as this survey from McKinsey notes. But it's not just a logistics issue. It can also impact cybersecurity. Now, remember, according to the UNECE WP 29 R155 regulation, it's the vehicle OEM responsibility for cybersecurity risks in the supply chain. Now, as manufacturers are looking to enhance and diversify their supply chain, they need to pay attention not only to the logistical and financial impacts on their business. It's also about making sure suppliers meet the required quality standards for their deliverables, especially in the cybersecurity domain. And why is that? Well, we know it's such a difficult task with the limited visibility and control and collaboration across the complex automotive supply chain. It's not simple to make sure that the components you get are safe and secure. And I'd like to share with you a brief example that we've witnessed at Cybersecurity. Next slide, please. So you might recall the Ripple 20 set of vulnerabilities that was discovered, I believe, a year or a year and a half ago, impacting commercial TCP/IP stacks that are widely used in the automotive, industrial manufacturing, and other connected devices space. Now, I've witnessed how an OEM and its tier one supplier both happen to be working with Cybersecurity, try to understand if these vulnerabilities impact their products. And it was truly challenging. You know, the request from the OEM came, the development team at the supplier already moved to another project, and as is often the case once an engineering project is complete. So it was really difficult to find the right people to do the investigation, understanding the real impact on components and which specific vehicles were actually affected by the Ripple 20 vulnerabilities was also very painful process. So to make a long story short, between internal analysis at the supplier, at the OEM, the escalation process, issuing a fix, understanding which vehicles are impacted, rolling out an update, it took over 4 weeks to resolve the issue, and that's for a single vulnerability. Next slide, please. So it is very difficult to secure supply chain, and the automotive industry is actually quite aware of it. As you can see in these findings from a survey we did with the ASRG, the Automotive Security Research Group, with about 45% of respondents saying it takes them 3 to 4 weeks or more for a single risk assessment. And that's just one vulnerability. So recalling Harald's slides, multiply this by the number of vulnerabilities you have and the number of models or variants that you have to manage, you get a complete nightmare. So there are solutions like the ones that we'll present you shortly that greatly help, but the challenge is quite clear. So to wrap this up, validating supply chain security issues is becoming even more critical than ever before, especially in these challenging days of logistics uncertainty as manufacturers trying to diversify the supply chain, introduce new suppliers that may or may not be vetted, may have issues or not. So it's definitely a critical issue and a challenge that needs to be addressed. Back to you, Harald.
Thank you, Guy. So to limit the threats now caused by cyber attacks and to improve the security of the vehicles, we have now new legislation in place. And those legislation have to be fulfilled, and both are mandatory for the type approval. So what happened last year was that the ISO SIA standard 21434 was released in Q3 2021, and we are now starting Q2 2022. And so the UNECE Work Package 29, the second legislation, Rule 155 for cybersecurity management, and also the 156 for the software updates, will be now mandatory for the type approval of new vehicles. And this is quite an hard milestones we are facing now. All vehicles will be affected then from 2024 onwards. And this is also a challenge because that means all the developments, if we're considering a development cycle of 4 years, means that all the developments we have started right now and will go to the market in 2024 will fall under this new legislation. So it has to be also considered today during the development phase. And let's have a look now how this legislation really affects the automotive development process, right? So we have seen in automotive industry that the most known model to explain the development process is the Lifecycle for the more hardware-centric and partially software development approach. So the industries are mainly following on the development stage, the concept phase, the simulation, the development of the powertrain components, also to integrate these components within the whole vehicle, to test and validate it up to the system, and then it comes to the type approval. Software is often developed in an agile approach, means in a DevOps approach, or within CI/CD toolchains. In the type approval, the OEM of course have to prove that the vehicle is according to the standards, and then the production phase started. In the in-use phase, mainly the OEM did some, we call it in German, Serienbetreuung or serial updates on the street, but these were minor developments which were released in the in-use phase. And this now completely changes with cybersecurity. The new legislation requires a cybersecurity management system which goes across the complete development stage over the type approval to the production and covers the whole in-use phase. So the OEM with his suppliers make to be sure that all the threats are discovered and the cybersecurity goals are derived out of this risk analysis, that the concept was defined for the vehicle, that the development is done on the state-of-the-art design, that intensive verification and testing, validation testing is done during the development phase. And the OEM has also to ensure if new CVEs, new common vulnerabilities, new zero days and so on are detected on the road, that these incidents are controlled, that these incidents are really flow back into the development, and that the OEM reacts with software updates to fix the issues. So we will see software updates, security-related software updates also over the in-use phase. What comes also in addition is that all this cybersecurity management system, it has to be certified. An OEM has to certify the system, also the tiers, and they have to provide evidence in the type approval that they were following all these different process steps. So they have to provide evidence that they have done security by design, that they have tested, they have to also provide the test results, the TARA analysis, the concept, and so on. And they have also to show within this evidence how they will react on issues that will happen in the in-use phase in terms of security. So this at the end, of course, is something which comes on top now in terms of legislation. It has to be considered. And we have also now to think how we can support the players in automotive to implement now practices, tools within their existing landscape to help them to implement their own cybersecurity management system. So maybe let's sum then up this challenging part or the challenger part in the presentation. So we have learned that software complexity and connectivity causes vulnerabilities, and those have to be managed in the life cycle down to the supply chain. And there's regulation now in place that impacts the development, production, and the in-use phase. And to support this integration, we have announced last week in partnership with AVL and Cybersecurity to support on this challenge. So together, our mission is to provide a tool chain that helps the OEMs, the tiers, the certification bodies to manage their vulnerabilities. And for us, it's important to have an automated management of those vulnerabilities because we have seen before the issues, they scale up with the complexity of the fleet. So it needs to be highly automated to save time, to save effort, and to save cost to comply to the legislation. Cybersecurity will integrate into AVL's cybersecurity framework. We have already a tool set on the market to support cybersecurity in tooling. As mentioned before, we have cybersecurity engineers and they have gained a lot of experience within projects. And our task within the software division is to bring this knowledge, this expertise into tools that will support the customer to be more efficient. We have in place a cyber process management tool, which is called AVL Fuse. It combines safety and security, and it has a cybersecurity process meta model inside that guides the customers, the users, through the cybersecurity process. It shows exactly what steps needs to be taken, what activity needs to be done, and helps at the end the customer to be more efficient in producing the needed deliverables for the certification. So it guides the customer through the process, and it supports the customer also managing this process with all these tasks internally and across the value chain. We are also working with customers together on the development of automated testing environments. Therefore, we are more in a prototype phase. So we are looking for approaches for possibilities to automate testing to support, for example, the pen tester, that he's concentrating really on the tough things and can take over the main testing part to the tools. And with Cybersecurity together, we are providing a software lifecycle management system for cybersecurity that includes on the AVL side our well-known AVL Creator tool, where we manage all the software versions and parameter sets. And on the Cybersecurity side, it combines Creator, or it expands Creator. It uses the Creator assets to do now high-performant vulnerability scanning and vulnerability management in an automated way. So, Guy, do you please explain us Cybersecurity and their product?
Sure, thank you, Harald. So Cybersecurity is focusing on securing vehicles and their components, and we are proud to be working with some of the leading OEMs and tier one suppliers and testing and certification organizations in the world, some of which you can see on this slide. In September last year, we were acquired by LG and remain an independently run company headquartered in Israel with offices all over the world. Beyond that, we are very proud of our industry involvement as we actively contribute to some of the leading cybersecurity initiatives in the automotive space, such as the ISO 21434, where our CEO was actually heading one of the working groups tasked at creating this standard, and other activities in many industry forums that can be seen here. Next slide, please. I think that one of the key reasons why this partnership with AVL makes so much sense to us is that both companies realize that software is essentially a living thing that keeps changing, and we need to address its entire life cycle from start to finish. So for Cybersecurity, this is part of our mission statement, as you can see here, enabling OEMs and their suppliers to keep the products they build and manage secure every moment of their life. This is basically based on three main pillars. The first one is automating product security so it can scale with the growing complexities and attack surface of modern vehicles. The second one is about staying compliant with the regulations, with the standards, and also with internal policies that many manufacturers have on their own via automated validation and providing the relevant documentation and reports in support of compliance processes. And the third one is to continuously monitor the security of vehicles and manage incidents once vehicles are on the road. Next slide, please. So what makes all of this possible? We have developed over the last few years a unique cyber digital twins technology that uncovers the characteristics of product software within device firmware without needing access to the source code. We basically create a blueprint of each vehicle component, including the software bill of materials, the licenses, hardware architectures, operating system configurations, control flow, API calls, you have it, a lot of information, providing the visibility and the context understanding needed to find vulnerabilities and remediate them across your entire system. And the great thing about it is that we keep updating this digital twin throughout the product lifecycle from design to operational use, so it's always relevant and can help in the assessment. Next slide, please. Now, based on this technology, our product security platform is able to cater for the key cybersecurity use cases, starting from the bottom when it comes to cyberborne management and supply chain visibility, to automated vulnerability management, licensing management to manage your legal risks that might originate from open source software or commercial software licenses. We empower the red team in their black box testing and zero-day detection through automation, and up to post-production threat hunting for cyber risks once the vehicles are actually on the road to make sure they can keep them secure. And on top of that, we enable compliance with the regulation and standards, as I mentioned, as well as an organizational oversight and governance that allows you to advance your security posture of the entire organization. You know, and this platform ultimately serves two products that we have. The product security assessment product handles the pre-production use cases, while the product security operation product monitors post-production issues. Over to you, Harald.
Thank you very much. So as mentioned before, we are targeting a software lifecycle management system. So we want to secure the software of the different ECUs within the different embedded software controller. So if we have a look on the control unit itself, on the one side, it consists, of course, of the software code. On the other side, it's also tailored to the different versions, to different countries, but also different PowerWare versions through the parameters. AVL Creator today is managing all the different software variants of the control units, including the parameter sets. And AVL Creator is supporting all the calibration teams. That means that it's a kind of database where they can find the latest version of the software, where they can do their calibration on a test bed or even in a car. And they manage all the different versions of the software and parameter sets within Creator. By nature, Creator was developed, of course, of the internal combustion engine, but over the years now, and also with the new powertrain concepts evolving on the street, it is also used, of course, for a lot of other applications, like control units for e-drive systems, for braking, for battery management, or for ADAS. Much more embedded software is managed by Creator. And the very unique thing of Creator is it manages all the different software and parameter sets for the different vehicle variants, down to each and every single variant. And that's why it's also really spreaded in the market. It's a market-leading tool, so we can really proudly say within AVL that 8 of the top 10 global OEMs, they're using Creator within their processes. And more than 120 automotive companies use Creator for their software parameter release to the car. So if you understand already, Creator is really integrated in the existing processes on the customer side. And if a new software version is released, it is imported at Creator. And within Creator, the calibration teams are doing the tailoring of all the parameters that makes at the end the vehicle unique or behaving in a unique way. And Creator is also integrated to the release system of the OEM, so it is exactly traceable what software version, what parameter set is really installed in each and every single variant. And for vulnerability lifecycle management, I think that's a crucial part, because then you can really take out your version, which is running on a street within a car, and combine it with automated vulnerability scanning from Cybersecurity. Within Creator 6+, we have all the REST API integration, so you can use the powerful REST API interfaces to the Cybersecurity tool. And Cybersecurity now takes over the vulnerability management and scans all that part and makes sure that every vulnerability is detected. What is the basic concept then out of this tool chain? So as mentioned before, the software is uploaded within Creator. We do all the calibration for the different markets, for the different powertrain variants. And we are creating a software binary at the end. And this software binary is then ready for a vulnerability scan. And this binary is handed over to Cybersecurity. Cybersecurity is creating a digital twin. We will explain that a little bit later. And then based on this cyber digital twin, the assessment on the cybersecurity is done on known vulnerabilities, on possible 0 days, and also on the policies and standard for software. And we get back to Creta all these scan results. So the Creta user can see within his fleet, do I have binaries or software parameters which are vulnerable, means we have possible 0 days detected, we have known vulnerabilities detected, we have maybe critical interfaces and so on. And he can decide later on the test results if this binary has to go back into the development, or even it's accepted for deploying the binary in the control unit in the car. And this toolchain is independent. So Cybersecurity, of course, is integrated to Creta. So it's a perfect integration, but it can use also separately and independently within the complete CI/CD toolchain of our customers. So we think it's a good add-on, good combination for the existing tool landscape of the customer to now add cybersecurity on top and to support to comply to the legislation. Yeah, so we have also prepared a little bit a demo for you to show it really live in the system, how this will work. So here you can see already our Creta user interface. On the left side, you can see here we are talking about a battery electric vehicle platform. And here you can see all the different binary or software versions for the different cars. So for the individual models, so like a city car, a compact car, and you can even see here the different versions of the software binaries we have now stored here. Those binaries are already checked, so have already a green light, so to say. So no severe vulnerabilities were found. Everything is okay. It can be processed and further on within the process. And now we would like to show how to scan a new version of the binary. So we will select the binary in Creta, what we want to scan. And we now hand it over, we download it, hand it over with the REST API to Cybersecurity for an automated scanning. You can see the different binaries. For us, very important that we have an integrated and automated approach. That means once a binary is uploaded into Creta, it could be scanned. We can also scan it maybe for software versions which are already in the car, deployed in the car on a time-triggered base. So for example, once a month, once a week, it really depends on the customer. And I think that's important because then continuous scanning is done on a monthly base for software version which are in the car. And if there are vulnerabilities, for example, for the Log4j vulnerability, which was really present, we can immediately see what cars are affected and what software versions are affected by this vulnerability. So in the meantime, the scan was done on the Cybersecurity side, and we can refresh the system and see the results back in Creta. So unfortunately, this was not successful. We have a risk score which is above a certain threshold. We have detected vulnerabilities, and this binary has to go back in the development stage to see if this vulnerability can really be exploited, if it is really severe, and then we have, of course, to take measures and to update a new version of this binary. If you want to see what really happens on the Cybersecurity side, we are offering reports and also direct link to Cybersecurity to follow up the issue and also see the different mitigation results, how we can mitigate the problem. Okay, Guy, that's from the Creta side. Yeah. Please explain us the Cybersecurity side.
Thank you. So as you mentioned, the entire process can be automated based on your policies, but this is how it looks behind the scenes. Basically, once we get the firmware from Creta, we create a cyber digital twin. Here you can see an overview of what we detected, and I'll quickly show you some of the information that's encapsulated in the digital twin, starting with the software bill of materials that shows a lot of information about the different packages making up this firmware. We can also export this SBOM in standards like SPDX or Cyclone DX, so you can share that with your suppliers or with anyone that needs to. So that's one thing. We can expose the licenses of the software in it, so you can enable you to manage policies related to it. We uncover keys, cryptographic algorithm, key sizes used in your solution, in your component. We show you the different exposed network interfaces and their complete path in the component. Really tons of information that's useful. We detect privacy issues, like privacy information, like emails that you may not expose or hard-coded passwords that you may not want to share based on your policy, and much, much more. But the most important thing is that we enable you to, we also support versioning, by the way, so you upload a new version, you can analyze it and see the progress you've made. But the most important thing is the assessments, obviously, and I'll briefly show you that. Here's an overview of the vulnerability assessment page, detecting CVEs that affect your code. And then if you go to the vulnerabilities tabs, because there are so many vulnerabilities, I mean, you can see the list, flat list here. We really want to help you prioritize those that matter the most. And we do so through contextual understanding of the components and understanding of the conditions at which the vulnerabilities may apply. So we automatically filter out those that are relevant for you, so you can focus on the real impactful vulnerabilities here. So for example, if I choose one here, you can see that this vulnerability here does not impact the component. We automatically detect it does not impact your specific vehicle component, and you can get much more information about it. Here you can see a bit more info about the vulnerability and its impact, but you can see also justification for its relevance. Here, a certain file is missing for the vulnerability to impact your solution. We can also provide you with relevant mitigation recommendations, but in this case, this is not really relevant. So actually touching on mitigation is obviously very important, and we want to help you with that by providing you recommendations on how to fix things. And we can also show you how resolving certain vulnerabilities can impact your security score. So here, for example, if you upgrade a certain package to a new version, it will resolve a certain number of vulnerabilities and improve your score by a certain amount. You can also use another method, our virtual analyst, which is a semi-automated wizard that helps you quickly resolve issues based on your policies and a set of rules and questions related to your risk tolerance of the digital twin characteristics. So these are neat ways for you to really focus, narrow down, prioritize the things that are important the most. Ultimately, from our experience, we find that through our contextual analysis, we can resolve up to, let's say, 90% of the issues, leaving your team with a smaller subset of real relevant vulnerabilities that impact your code. And this is a great and important time saver. Now, beyond the known vulnerabilities, we can also analyze your code for coding errors or 0 days. As you can see here, in another component, this is a 0-day analysis that we've created. As you can see here, there are several 0 days that were detected. This one that I'll choose now is a Stack Overflow. If you want to get more information about this issue, you can get a short story explaining the issue. You can also access our very extensive knowledge base for more information and understand more about this vulnerability. And obviously, you can get the remediation recommendations on how to exactly fix the problems. You can open a ticket, send it to your, in Jira, send it to your R&D, and fix that. Now, finally here, I want to show you a quick glimpse into the governance dashboard where you can track aggregate KPIs, such as the highest risks or open tickets. and so on and so forth. And you can also drill down for any of these for more information. But that's a quick overview of our governance dashboard and a quick glimpse into the backend of the Cybersecurity platform. Back to you, Harald.
Thank you very much. We are already at the end of the presentation. I hope it was interesting for you. You get some valuable insights. Let's sum up the session. So regulation is just around the corner. In 3 months of time, the new cybersecurity regulation is mandatory for the type approval for new vehicles, and in 2024 for all the vehicles. And the new regulation mandates a lifecycle approach. That means affecting all the vehicle models down to the single variant that needs to be considered. The third takeaway is that we need some automated tools because vulnerability management is not easy to handle manually. And those tools have to be automated and fully integrated into the customer landscape. And we think it's really a prerequisite for successful managing all the vulnerabilities. And AVL and Cybersecurity, with this partnership together, our mission is to automate vulnerability management, to use the huge asset of Creta, that we combine vulnerability management into a complete software lifecycle management. And we are really open, Guy, myself, to get more into contact with you about your situation, about your challenges on site. So really contact us. Here are our email addresses for further questions or for more deep dives into our solutions and into the demos. Yeah, so we are at the end of the presentation. Thanks again from our side for listening, and I hope we have some interesting questions now. Back to you, Freddie.
Okay, fantastic. Thank you, Harald. Thank you, Guy. Yeah, we've got a bit of time now for Q&A, so this is where we pass it over to you, the audience. Just to reiterate, if you would like to ask a question, you can just type it straight in. You can see the Q&A box at the top of your screen there, next to reactions and more. So just type it in and we can put them to our experts. We do have a few already to work with, so thank you for those. Guy and Harald, I think what I'll do is ask the question and then let you decide who is best placed to answer it, or perhaps both share input. The first question for you here is, why is Creta the right system to start vulnerability management?
Mm-hmm. Yeah, thank you for this question. I think that's really important. As mentioned below in the slides, it's the system that is connected to the release system of the OEM. So we have all the status ready. If this binary is in development, if it is already deployed within a car. And we have also the software in combination with the parameters. And also a parameter could also be, basically spoken, a switch that switches on functions within a car. And this function can then also bring vulnerabilities. So you can also switch on via the parameter vulnerabilities. And we think it's good to start with the binary in Creta because it is, at the end, it combines all that stuff that is needed, and it's fully integrated in the customer process down to the release system.
Fantastic, thank you. This next one is also about Creta. What needs to be done at the existing Creta licenses to support vulnerability management?
We need the REST API function to integrate Cybersecurity, and this function is available with the version Creta 6+. So all the existing customers which have already 6+, they can easily integrate Cybersecurity for the vulnerability management. And for those customers who have a lower version, they need to upgrade it to the 6+. Then they can use the powerful REST API. And then they can integrate it in the CI/CD tool chain, and including, of course, Cybersecurity.
Okay, fantastic. A bit of a broader question for you here. Could you just summarize again, you did touch on this a few times, but could you just summarize how the semiconductor shortage is affecting the cybersecurity market?
So as we discussed before, the current challenges in the supply chain basically force OEMs and manufacturers to diversify their supply chain. They are introducing new or other partners that they may have worked before or not, or have not worked before in the past, and you know, this is definitely a burden. And typically, when people think about it, they're thinking it from a financial perspective, from a business perspective, which is obviously extremely important. But there's an important quality aspect here. So the fact is that you have a new supplier there that might not be abiding to you know, standards and rules and your own policies regarding cybersecurity, and you need to make sure you can get control over that. So it really introduces a lot of noise there, a lot of problems in, you know, just vetting these suppliers, and you need to make sure that, you know, ultimately they can deliver you the quality components or products, not only from a timing perspective, from a quantity perspective, but also to make sure that the quality, and cybersecurity is as an important element of quality, so that, you know, you will not introduce new risk and new vulnerabilities into your products.
Then, Guy, maybe another, just a quick question here. One listener has asked, is Cybellum automotive specific?
So we focus on the automotive industry for the past 4 or 5 years, I think since 2018, give or take. We do diversify our offering. We do support also some industrial manufacturing components and medical devices, but our core competence is in the automotive space.
Okay, fantastic. Thank you. Next question for you here. How is a cyber digital twin different to a software bill of materials? The second part of that is, do you need the software bill of materials as an input for the digital twin generation?
Good question. So a cyber digital twin contains an SBOM, a software bill of material. It's not the same thing. It includes so much more data, as I mentioned before, the hardware component, the interfaces, the API, the control flow, the what you not, and we actually automatically generate the software bill of material from the binaries, from the firmwares that we get from Creta. So we don't need it to create a cyber digital twin. If you do have one, you can input that, but it's not mandatory. We can create it on our own.
Fantastic, thank you. Next question, do you need to integrate or add any pieces of code into the vehicle or in particular components in order to enable vulnerability management?
Good question. So the answer is no. Our solution is completely off-board, agentless. So you don't need to integrate any piece of code or anything on your component or vehicle. Basically, we use that live dynamic digital twin that we create, and we keep updating, because every time we have a new release, we get it from Creta, or, you know, through our own API integrations with OTA systems. You know, we are pre-integrated with many over-the-air update systems, so we keep the cyber digital twin always up to date. We know what you have in the different components in the vehicle, and we automatically also track threat intelligence from multiple resources, from, you know, the dark web, through vulnerability databases, and so on and so forth. And we're able to automatically correlate and produce automatic impact analysis to make sure that we can alert you on any new or upcoming threats to your vehicle. But there's no need for any integration into the vehicle or components themselves.
Brilliant, thank you, Guy. One listener would like to ask, can we use Creta for vulnerability fixing or patching for the software components after the scan is done?
I think that's also a very good question. So you cannot use Creta for really fixing the issue. It has to go really back then to the development. So Creta tells you what versions or what binaries are affected, contains vulnerabilities, and you can then check again. So it's a kind of lifecycle management system. But the real fixing, so is it a vulnerability that is really severe and can be exploited, all that testing that needs to be done, all that fixing then comes afterwards, and all the validation then back if this fix is really successful or not, needs to be done in the development phase as well. When the new binary then is available from development, we will again check it in and again scan it. And if the scan is then successful, it will go further in the process.
Fantastic. Thank you, Harald. Next question for you here, guys. Can this ecosystem work on legacy systems, or can it only be used in new projects?
I think maybe an answer from my side, it could be used also for legacy projects. Once we have this binary available, also older ones from years ago, we can upload it in Creta and we can scan it on the Cybellum side. So it is not only for new projects, it could be also used, of course, for all the binaries generated in the past.
Yeah, that's a perfect answer. As long as we get the binaries, the firmwares of the ECUs, we can scan them, we can create a digital twin, we can do analysis and provide you any alerts on any issues that you may have there.
Good stuff, thank you. Got a question here about customer support. Could you just talk to us about that, the kind of support that you offer at the start, and then sort of how that goes through the process?
Mm-hmm. Yes, maybe I start again. So in the partnership we have announced together with Cybellum, AVL takes over the role, of course, to offer this tool to the market. So we are the face to the customer at the end, also for the Cybellum product, in combination, of course, with AVL Creta. And Cybellum is supporting us in this sales phase a lot. So at the end, we go really together also to you, to the customers, and support you will be the best fit for your processes and for your situation. When it comes then to operation, also AVL takes over the service level support. If it goes then deeper into some fixing in the service, in the operation, then Cybellum will take over, because Cybellum is, of course, the specialist with their own product.
Correct. Perfect answer. We have also our own dedicated customer success team that works together with AVL and with our customers in these cases, and we have structured onboarding processes, support processes, and so on and so forth, and we help. We jointly work with AVL on supporting the success of our joint customers.
And I think to that point, would you mind just giving us a bit more insight into, or I guess background into, the partnership between AVL and Cybellum? How did it come about? And I guess what do both of you bring to the table, this sort of complementary expertise?
Mm-hmm. Yeah. I think it's a very good question. Yeah. If we go a little bit back, maybe last year, we have all seen that cybersecurity gets a really, really important topic for the automotive development process, and has impact, of course, of the complete life cycle. And we have also started our own engineering projects within AVL, and we have seen also that this is really a challenge to master. And so we were thinking about how we can really help our customers in putting more automation within their processes to save really time and effort for really comprehensive lifecycle management. And so we had already some touch points with Cybellum together, and we saw that's a perfect fit with our lifecycle management tool, AVL Creta. And we were really convinced about the technology and the performance of the product. And that's why our discussion intensified. And we really have a common ground there in our communication to Cybellum, and we feel really comfortable that we can bring out the solution to our customers that make an impact out there.
Yeah, definitely. I think there's a good match, a good understanding, and a good, I think, fit in terms of our approaches to how software need to be managed, and from the Cybellum perspective, how cybersecurity for embedded software components need to be managed. It's very, very much aligned. So I think there's this definitely natural understanding and we feel very comfortable with that, and that's why it makes this partnership so convenient and interesting from our perspective. Plus, having the fact that we have Creta as a major tool that enables you to manage the software and the parameters, and it fits so nicely with the Cybellum approach of having always this consistently updated view of what's going on in the vehicles, and be able to maintain the security not only during the development, which is obviously very important and critical, but also once the vehicle is out on the road. I think that made sense for both companies, and that's why we partnered.
Maybe to add a little bit for the understanding, our goal is as well to make really the customer compliant to the new legislation within their ecosystem, within their tools the customer is using. So Creta, of course, is widespread and is a tool for lifecycle management. For other customers or for other companies which don't use Creta yet, they can also, of course, use Cybellum with their integrated tools already they have for software lifecycle management. So Creta does not necessarily need Cybellum, and the other way around as well. So it's fully integrated, of course, within this bundle, and it works efficiently. But it can also fully integrate it into the existing CI/CD tool chain. It does not really Creta is no prerequisite there, so you can also use, for example, Cybellum with your solutions you have already installed.
Good stuff. Thank you both. And maybe if I can just finish with a bit of a broad industry question. The conversation around cybersecurity is obviously relevant for the entire supply chain. I just wonder, and obviously without naming names, could you talk to me about maybe which stakeholders, which players are either best prepared or working the hardest to bring vulnerability management into their approaches here? Is it the automakers that are sort of making the most progress? Is it the big tier ones? How are the smaller suppliers getting on? Could you sort of share any insight here?
Sure, I can give it a first answer. So first of all, this is a challenge that's definitely impacting the entire supply chain, both OEMs and tier ones. The OEMs are the ones that are obliged by the regulation to they own this issue. So it's their top priority to make sure that they are compliant, they can get type approval, and they can sell their vehicles in the market. So it's the onus, the responsibility is on them. And we are seeing slowly that the industry is starting to align around that and put in place the processes and technology needed to come up with a CSMS system to certify the different vehicle types with it, and to make sure they're ready for the July, the first milestone, which is coming up in July this year, just in three months time. So I think there's definitely a lot of focus on the OEM side. It's not that everyone is taking an automated and integrated and really unique approach like we are showcasing here, but I think I believe there's a huge potential here, and everyone will have to ultimately come up with automated solutions like the ones we showcase today, because otherwise it will simply not scale.
I can also confirm that, what Guy mentioned, we can see customers really fragmented in their situation where they are. So we have some customers will really deep dive with us on different topics in engineering and want to really develop with us components on cybersecurity. And other customers, they're asking what they have to do to be compliant to legislation at the end, and what work products do I need to generate at the end for the certifier. So they need some process guidance and process know-how. So it's completely different, I would say, but I think that this is really important, and there's an important milestone this year and in 2024 that's, I think, broadly known in the industry.
Okay, fantastic. Well, I think with that, we can bring this session to a close now. Thank you very much, Harald and Guy, for sharing your insight with us today. Much appreciated. And thanks also to AVL for supporting the event. Just a quick reminder that today's presentation slides and an on-demand version of the session will be sent out to you, so just keep an eye out for that email. That's all for today's session though, so thank you all for listening in, and goodbye for now.
Bye-bye. Thank you.
Bye-bye.